Okay. Good morning, everybody. Hope you all enjoyed your elongated coffee break. So we're back with our first panel session, second session of the day. So I'm Andy Purvis. I look after sustainable manufacturing with worldsteel, and it's sort of been my role to pull together this panel this morning. And I think hopefully it's something a little bit different. We talk about climate risk, obviously, within worldsteel, and it's often seen as a sustainability issue, an environmental issue. But I hope that the session we're going to have now will show that that's not necessarily exclusively the case. It's becoming operational, it's about infrastructure, it's about resilience, and a strategic issue for our industry. So we're going to look at this topic from three perspectives. First, insurance and investment. I'm delighted that we have folks from the insurance industry who are really keen to engage with us still on this topic. Secondly, around, physical risk facing steelmaking, and Dr. JANJUA from worldsteel will be talking around that. But third is, I think, the operational reality of climate change and the reality of a major climate-related event, which is something that was really experienced by POSCO a few years ago as a result of a typhoon, which we'll hear about what happened, the flood, the recovery, which is an amazing story, but also critically when the dust settled or the water was pumped away, what changed in terms of the way POSCO looks at this kind of risk and how they manage this kind of risk. What assumptions were wrong? What changed physically? What changed organizationally? And what that might mean for the way that all of us think about risk and think about investment and think about our assets. So I would like to invite my panel, my speakers, to come up to the stage, please. I'm blinded now. I see Ben, Maryam over there. Rizwan, please come up. Mr. Lim. Mrs. Lim, who will help with translation when needed. So thank you. So with that, I would like to invite Dr. Maryam GOLNARAGHI to begin. Maryam is Director for Climate Change and Environment with the Geneva Association, which is an insurance industry body. But I will leave you to introduce the Geneva Association. Maryam can't stay with us all day, so she will disappear stage right as we get into the panel because she needs to get a plane to somewhere else, but we're delighted you could join us. So, Maryam, please. I will steal your chair.
Excellent. Okay, I think there are going to be some slides here. Well, thank you very much. Okay, perfect. Thank you to worldsteel for this kind invitation. It's a pleasure to be here, and really thank you for organizing this panel. I think you will have an excellent discussion. My name is Maryam GOLNARAGHI. I'm Director of Climate Change and Environment at the Geneva Association. Geneva Association is the international think tank of the insurance industry. Our members are 90 CEOs of largest insurance and reinsurance companies globally, 24 trillion of assets under management, and together these companies underwrite more than half of global insurance policies. So what we do is we look at critical issues of the future that impact the insurance industry or the insurance industry could have impact on. My role as the Director of Climate Change and Environment is to develop innovative solutions leveraging the expertise of the industry in the areas of resiliency of core business, and also helping industrial sectors to expedite their decarbonization. So to give you an example, we are working with oil and gas companies on scaling up carbon capture storage by really rethinking the risk framework, de-risking, and reducing cost of capital for scaling up. And I had the pleasure of talking to Edwin yesterday around the needs of your industry, which we've worked with you actually actually, we worked with World Steel for the last year, and where is it that we can potentially pull our expertise, maybe in area of hydrogen or other areas where we can really move faster towards scaling because of shared expertise and the de-risking function that insurance industry can bring. But today I'm going to talk about core business resilience. We are living in a business environment where there is growing uncertainty, whether there is shifting geopolitics, we are going through that, trade tensions, supply chain disruptions, energy insecurity, and now rising physical climate risk. Now, in the last 2 years, I have spent a lot of time working with executives across 6 major industrial sectors: cement, steel, aviation, data centers, buildings, and so on. And it looks like really developing resilience in core business is now becoming a front and center concern for the executives. Now, when you look at the last 3 decades, you'll see that direct economic impacts and insured losses from extreme weather has risen dramatically. If you look at 2020 onward, the total insured losses has been over $100 billion annually, and insured losses only account for 1/3 of economic losses. That means we still, are not capturing everything through insurance, and that is particularly in areas such as Asia, South America, and other regions where the insurance protection gap is quite high. Now, the other point that I want to raise here is when you look at insured losses over the last 3 decades, you see that 55% our losses are from what we call secondary perils: wildfires, floods, convective storms such as hail. It's not the hurricanes and typhoons. So you don't need to be having your assets and operations along a coastline or by a river to experience this. You could be facing a major flood, like a flash flood, because of where you have built and how you've built. So this is something that I wanted to make a point. Now, let's start looking at. So how extreme weather could impact your business? And I have highlighted a number of issues here. First of all, I'm thrilled to hear about your progress with your decarbonization, your sector's decarbonization planning. A deep understanding of how extreme weather and slow-changing trends like water scarcity, extreme heat, could impact the billions of dollars that you're going to invest in developing new sites, new infrastructure in the future, is going to really impact the way you design your decarbonization planning and operations. Now, also, extreme weather impacts your assets and operations, with damage and disruptions increasing your cost of retrofits, relocation, and maintenance costs. Project-level development and delivery, where construction delays drive cost overruns and uncertainty. Workforce, where impact of extreme weather, for example, extreme heat, could reduce productivity and also increase your compensation costs. Stranded assets, if your assets become uninsurable over time, which is happening in many regions, particularly currently in the United States. Supply chain disruptions and vulnerability, when something that happens in this part of the world will impact your operations in another part of the world, but we are not looking at these interconnectivities in a system view. Critical infrastructure and utility system repair delays that are being managed by, for example, public authorities. That could disrupt your distribution, it could disrupt your business. And then what we are observing is rising climate litigation risks. Companies that do not properly manage resilience of extreme weather being actually litigated against by their investors and their shareholders. Now, if we go to the next one, My next message is that these losses, ladies and gentlemen, is not just driven by climate change, by intensification of extreme weather. They are linked to decisions that a wide range of stakeholders are making that's increasing the exposure and vulnerability of the businesses. Let me highlight 5 issues. First one is where we build. Across the world, land use decisions by local governments and businesses often prioritize economic development and cost savings over risk exposure, and construction continues to expand in what we call hazard-prone regions. Second one is how we build, and that's very relevant to your industry, being in the value chain of the built environment. Adoption and enforcement of updated building codes are always delayed because of political lobbying or cost pressures. Third one is inadequate capacity or poorly maintained critical infrastructure and utilities. In fact, most wildfires around the world are caused by poorly maintained power utilities, power lines. Or also most flash floods around the world are caused because of lack of capacity of water and sewage systems. Fourth is our approach to urbanization, densification, expanding wildland-urban interface, destruction of natural ecosystem which serve as buffer for floods. And then last but not least, which all of you I'm sure experience in your business, is cost of reconstruction, which has increased between 30 to 50% depending on where you live following COVID because of supply chain disruptions, tariffs, and inflation. Now, my third message is you cannot solve these problems alone within the boundary of your companies, because the risk profile of your assets and operations and your business is being impacted by a wide range of decisions that are being made by a wide range of different stakeholders. So from those that are involved in land zoning and building codes, to asset owners, development and construction, those that are valuing your assets, the lending sector, and so on. And these have all been detailed in the work that we've done. Reality is, if we want to tackle this whole issue of resilience of core business, it is not a single company or even a single sector problem. It's a system-based problem that needs to involve engagement by a wide range of stakeholders. Now, my fourth message is that rising insurance costs and growing coverage constraints in the absence of risk mitigation in your assets and operations are beginning to shape where projects are built and how they are designed, operated, and maintained based on insurability of what you plan to build and how you've designed it. In other words, you may decide to build somewhere and you go to your insurer before financing and they say, sorry, I cannot cover it all. And we are observing that, for example, with solar farms. Solar farms that haven't been designed for hail or floods are not securing insurance. So you got to go back to step one with your engineering company and redesign it. This is happening across many different assets and operations. Now, insurers traditionally are engaged after the site has been selected and the project has been designed before financing. But that's too late. I think one of the issues that you will discuss here is that engaging insurers, risk engineers from very early stages, from site selection, can help you assess potential risks over the life cycle of the project you intend to build or the project that you have built, and that can help you in identifying risk mitigation measures that can be part of the design of the project or part of retrofitting of that project. And then now my final message is that we talk about cross-sectoral collaboration. It's a very easy thing to talk about and a very challenging thing to actually do. What we were observing this morning as Asa was giving the presentation, this is almost the same presentation we give to our own CEOs. So across our sectors, we're speaking exactly the same topics, exactly the same challenges, exactly the same solutions, but we just need to realize that we need to bring this together and start working on the ground. We need to go from sector-specific conversation to cross-sectoral engagement for collaboration on the ground. And this is where, again, I'm looking forward. I see this as a beginning of a new conversation for us with the steel sector to explore the areas that we can collaborate, not only on building core business resilience, but also as you endeavor to decarbonize your industry and your business models, how we can do that, taking resilience into consideration. Thank you so much for your time, and I pass it to you. Thank you.
Thank you, Maryam. That's great. I think Maryam really helped frame the challenge. And now we're going to hear another insight from the insurance industry. Ben Kinder is here. Ben is Chief Underwriting Officer with Tokio Marine. Ben is going to help us really understand what this challenge looks like from a practical investment and insurance perspective. So thank you, Ben. I think the time is about right.
Perfect. Thank you. Yeah, thank you, Andrew, for the privilege of presenting. Obviously, when you took the poll earlier around people's knowledge of the steel industry, I was that guy at the bottom. So it's been an incredible learning curve for me so far, and I look forward to learning a lot more in the next couple of days. But one thing that came out in the first presentation was a lot of your challenges are very similar to a lot of the challenges I have. When running an insurance company, around frameworks, regulatory frameworks, reporting, accounting, the lack of consistency across accounting standards, reporting standards, requirements from all the different stakeholders. So if I could have rewritten my speech in the coffee break, I would have done, because a lot of that resounded with me. These are the same challenges I have around talking to my capital providers, my shareholders. So I think I can honestly say I do think that we're all in this together. So just as an introduction, my name is Ben Kinder. I'm the Chief Underwriting Officer at Tokio Marine GX. Tokio Marine GX was formed, we launched it in the 1st of September last year, and it is the decarbonisation division of the Tokio Marine Insurance Group. Tokio Marine Insurance is the 6th largest insurance company in the world, $90 billion market cap, and we have a significant ambition to support society and the decarbonisation of society through insurance. So I am the insurance guy in the room, so please don't hold that against me. And I can't get you cheap motor insurance, and I can't, if you lost your suitcase at Brussels Airport, which yesterday I believe was a disaster, I can't help you with that either. But I also sit on the advisory council of the Geneva Association with Maryam, and we reported on the sectoral decarbonisation, and the insurance serves as the foundation for much of what I want to say this morning. Over the next 2 days, you will hear, I should have put some slides up. Over the next 2 days, you will hear about the factors that will shape the future of the steel industry, from new technology and policy to the availability of clean energy and green hydrogen. However, the future of steel will also be shaped by whether the risk of building that future can be understood, quantified and transferred to insurance companies like myself. Whether the projects that need to get built can get financed, whether capital flows at the pace and the scale of the transition required. So again, there was a comment around there's $65 billion of capital coming in to the industry over the next sort of 20 to 2050. How is that capital insured? How are those banks being given the confidence to lend that money to your industry, knowing that they're going to get the returns that meet their regulatory framework and their shareholder requirements? The green transition is poised to spark the greatest capital reallocation in a century. The risk transfer market must evolve, embed stability, and reduce the volatility that has historically stymied progress. The Geneva Association recently published a report on how the insurance industry can support that different sectors in decarbonisation. I contributed as a committee member alongside colleagues from across the reinsurance and insurance industry, and the representatives from the steel, cement, aviation, oil and gas, and data centres and building industry all gave us their input. And it's very important for us as an insurance industry that we listen to your industry and what your industry requires from the insurance industry. I mean, I think historically the insurance industry has been very siloed, very verticalised, and has always imposed their product onto industries. And now I think the mindset needs to be that the insurance industry needs to listen to what you need to do your business. And I think the slide that become more relevant was the slide about enabling. Insurance companies should enable your business to do your business and not become a blocker, as has often been the situation in the past. So yeah, just a brief agenda. I'll run through that very quickly. Introduction, the capital challenge, where we still see decarbonisation pathways, the lender's view, again, the three strategies for steel, what we are trying to do at Tokio Marine GX. And again, Tokio Marine GX is supporting multiple industries along this journey. So then there is some precedent set there around what we've done with the offshore wind industry and how we've supported the development of the offshore wind industry and where it is today. And just a few final remarks.
5 minutes, okay.
Okay. Understood. Right, where are we? The scale of what the industry needs to do is extraordinary. 1.9 billion tonnes of crude steel a year, decarbonisation pathways that include hydrogen, direct reduction, large-scale carbon capture and storage, electric arc furnaces, powered by clean energy, and eventually a fundamental shift from trading iron ore to trading green iron. These are capital-intensive, technically complex transitions. Many of the key technologies are still pre-commercial. The finding that came up again and again from steel companies, from project developers, from financiers, was the biggest bottleneck is not ambition, and it's not technology, it's capital. Getting the investment to flow of the pace and the scale of the transition requires. That is where insurance comes in, not at a cost, but at a catalyst. Think about what a bank or investor sees when they look at a first of a kind hydrogen direct reduction plant. Technology that has never been built before at scale, with no track record of performance, a supply chain that doesn't fully exist yet, and it is something that goes wrong, liability that could run for decades. Without someone willing to stand behind those risks, the lender either walks away or prices the uncertainty into financing costs, making the project unviable. Insurance doesn't add to the cost of that project. It removes barriers to innovation and investment. It can make the project possible. And it needs to be involved early, as Maryam said. If an insurer first learns of a hydrogen direct reduction project after the site has been chosen and the equipment specified, it's too late to shape that project's risk profile. The cost of insurance, if available at all, will reflect the lack of engagement. The most valuable thing insurers can do in the room during feasibility and site selection, early involvement improves the asset design, reduces the risks, reduces the premium, and accelerates the financing timeline. For steel companies and their investors, this is not a marginal benefit. It is the difference between a project that gets built and one that doesn't. The Geneva Association report identifies 6 strategies for accelerating deep decarbonisation across hard-to-abate sectors. 3 of them are directly relevant to this room. The first is taking a value chain view. Green steel projects don't sit in isolation. They involve iron ore supply, green hydrogen production, power purchase agreements, CO2 transport and storage, and downstream customers with their own carbon commitments. A single failure anywhere in that chain, a hydrogen supply disruption, a CO2 storage incident, cascade across the whole system. Insurers who map those interdependencies from the outset can design cover that reflects the whole project, not just individual assets. This is what makes a complex project bankable. The second is standardisation. For mature technologies, established risk standards exist. For hydrogen direct reduction and industrial carbon capture, they largely don't exist. Insurers have a role in helping to build these standards, the same role the German Insurance Association played in developing the offshore wind standards that helped the industry scale. Standards enable replication, replication enables scale. The third is early engagement. The report is ambiguous. The current project finances model, where insurers are brought in after key decisions are fixed, needs to change. Insurers need to support businesses at every stage of the transition journey, not just at the point of closing. Last year, I helped launch a business called Tokio Marine GX. The green transition is set to require 9.2 trillion in annual average spending on physical assets. And yet the insurance market serving that transition was fragmented and inadequate. The lack of cost-effective, global available cover has become a barrier to progress. A company planning a wind farm would need marine cargo cover from one market, construction cover from another market, tax credit protection from the third, each from a provider with different expertise, different appetites for something as complex as a green steel project. That problem is more acute, even more. The Tokio Marine GX was launched to address this gap, reduce volatility and embed the certainty that market needs to flourish. It is built on the foundation of a company called Jeewoo, which has been at the forefront of the green energy insurance for 25 years. Facilitating innovation, enabling investment, mitigating risk, and paying more than 1 billion in claims, Jeewoo has supported 2,000 projects across 40 countries, and Tokio Marine Group today insures assets generating over 100 gigawatts of renewable energy worldwide. What GX offers is a single point of access for integrated cover that transition projects actually need. Construction and engineering, technology performance guarantees, project cargo, carbon capture, hydrogen risks, credit and surety risks, and carbon credits in carbon markets. We offer up to $500 million of capacity for any one risk, and we enable new technologies and projects that will change our world for the better from concept to completion. But more than products, the GX offers is a different kind of engagement, one that starts at feasibility stage, one that understands the value chain, not just the individual assets. Yep. Yeah. So 20 years ago, offshore wind was emerging technology with a capital problem. The technology was novel, the risk data was thin, the insurance market was uncertain, and lenders priced their uncertainty into financing costs that made projects marginal. GQ made the decision to engage early, to build knowledge alongside the technology to help develop the standards and frameworks the market needed. Over time, the early engagement helped unlock investment at scale, and offshore wind is now one of the most active and insured sectors in the energy transition, with deep market capacity and sophisticated cover frameworks. I truly believe with the engagement from yourselves in this room, the insurance industry could do that again for the steel industry. Thank you very much.
Fantastic. Thank you, Ben. So we've heard an insurance industry perspective, why resilience matters. Dr. Rizwan JANJUA, Head of Technology with WorldSteel, is now going to help us understand really where some of these vulnerabilities lie within the steel industry. So Rizwan, please, thank you.
Thanks, Andy. I was told that I've got 8 minutes, so thanks for the additional 2 minutes. I will make every minute count, so stay with me, if you will. So the presentation is about the climate risks faced by the steel industry going forward the next decades. Around 2020, I took an initiative, put together a report. I was supposed to present that to the board, but COVID hit, and that presentation was never made. And then I created a report that was circled around, and you can make a guess how many people read that report. So always, whenever things like that are talked about, the first reaction is that it won't happen to me. So I don't need to worry about such kind of stuff there. So let's see. So I'm going to put together the steel industry context, why water is important for us. Then we are going to have a look how much water stress we can expect now and going forward. And of course, then because we are talking about the climate change risks, if there is any sea level rises, how much of the coastal flood risk we can expect. So everybody knows that we produce around 1.9 billion tons of steel every year. And the main production routes are primary, which is BF, BOF, 2/3 coming out of that, and 1/3 coming out of the scrap route. And of course, we have got a small portion of DRI, EAF as well. And in terms of water use, and we are not talking about water consumption here, so it means that most of that water stays in circulation. So it gets recuperated. So a lot of the material preparation requires water use, cooling, but of course there are some losses as well. Evaporation and anything that we cannot clean will be lost. So the biggest consumer of water or use is the primary route, and then the EAF. The DRI, EAF, we are talking about natural gas here. And if we talk about the direct reduction using hydrogen, that is not there. So this does not reflect that reality there. That is going to add another 1.5 cubic meters of water to that. And let's not confuse the two things. It's not water use. That will be the water consumption. Because if the hydrogen is made at a different place and moved around, it means that that water is leaving that area, that geographical location. So you can, for all intents and purposes, call that water consumption. So that's not water use. So that's another reality that we should be mindful of when we talk about hydrogen. So let's have a look about water stress. So this is basically the heat map, how much water stress is there around the world, and see where the steel industry fares there. So what I did was that World Resources Institute publishes every now and then water stress indicators. The project is called Aqueduct. The last time I did that analysis, it was Aqueduct 3, and now I have used Aqueduct 4. So they have got around 1,300 basins, hydrological basins around the world. That includes water from all sorts of sources, underground water, lakes, rivers, and everything that is there. And they have been working with a few scenarios. If my laser helps me there, no, it's useless. So there are 3 or 4 baseline scenarios that they have been working with. The optimistic, pessimistic, going 2030, 2050, and 2080. And the risk assignment is that you take the map, you have got those hydrological basins, they come in sorts of different polygons, and you take the push pins and you point them there. So some nerdy stuff, I'm not going to bore you with that. So what I did was that capacity aggregation, so how much of those risk categories can be assigned in those different pathways. So the outcome is that how much that shift takes place over time. So we need to be mindful of that the capacity is geographically fixed. You are not moving the sites, but the risk itself is changing over time. So the portfolio is having kind of a chronic stress. So now, if we look at the baseline, we can already see that most of the steel industry capacity, that is 1.9 billion tons of steel, is already lies between high and extremely high water stress regions. The business as usual, optimistic and pessimistic, they all tell us that all of those categories, and stay with me, this is like trying to explain a weather report. They are moving from the low risk to high risk upwards. So the green areas, they are kind of shrinking, and then the amber areas, they are increasing. So it means that in any of those scenarios, going forward, we are going to see more stress, water stress. So what those indicators are, I have worked only with one indicator, which is the baseline water stress. There can be all sorts of things there. Depends on the geographical context there. If there is any risk of drought, flooding, rivers, for example, if there is too much water, not enough water. So all of those risks, one side can analyze their own exposure to those risks. It's quite easy to do that, to be frank. So let's have a look at the coastal flood risk. And that's a very, very small basic modeling that I did. How close you are to the coast, and what's the elevation of the site. So starting from less than 2 meters proximity to the coast, all the way to 20 meters, assigned it a score, 5 to 1. And the same way with the distance, less than 1 kilometer to all the way to 50 kilometers, a score assigned there. And the exposure is calculated by assigning 60% of the weight to elevation and 40% to proximity. So now in these rows, you can see that the highest risk is faced by roughly 330 million tons of steel capacity, 120 sites around the world. So the exposure is not driven by operations. I did not look into what sort of those sites are, but rather the topography. And again, it's a very, very crude analysis. It does not tell you the elevation profile of those sites there. If, for example, the sea level rises, or if there is any flooding that happens there, if the water is going to go into the site, or if it goes there, if it can easily recede. So that is a next step that I'm going to propose. So we analyzed two dual risks, the water stress and the coastal flooding. So some of those sites, they might be facing both of those risks. What it does and what it doesn't do, that it gives a relative exposure, not an absolute one. So if you have got the site which is having those kind of exposures there, does not necessarily mean that you are going to have that risk, and that's where the complacency comes in there. It's not going to happen to me, because it didn't happen for the past 10 years, 20 years. But it doesn't mean that it's not going to happen. So it gives you some kind of an assurance that you are at an immediate risk or not. It does not capture, for example, the flood intensity or any of that deeper modeling, which can be done as the next step. So what can be done by a site? You can do flood risk modeling, check the acute risk, for example, the site level digital elevation modeling. So technologies are there. You have got the LiDAR, you have got drones. I've said the D word. You can check the profile of your site. If the water comes in, how much, and how much is going to recede there. The data or the elevation that I got there, it's a very, very crude coming from NASA. It just tells you the average height of a location there. It does not give you the profile, but with the deeper elevation model, you can create a complete digital profile there. And that gives you much bigger understanding of what your site looks like. And then the basin level water computation, and that requires a deeper GIS analysis there. How much the community is built around the site. What's the competition between the users? If there is a lot of industry, there will be a lot of competition among the users. And then you can speak with the insurers. So that was it. Thank you very much for your attention.
Thank you. Thank you, Rizwan. So we've heard some theoretical analysis, but that's not where it stops. So I would like to welcome Mr. Lim from POSCO, who's really going to take us from the theory to reality and what really was experienced at Pohang. So in context, Mr. Lim is Executive Deputy Head of Pohang Steelworks with POSCO. Mr. Lim? Oh,
yeah.
oh, I'm sorry. There we go. There's the introduction.
Yeah, okay. Thank you.
So thank you. You have your time on there. That will take you forward. Thank you, Mr.
Yeah, don't worry about that. I keep the time. I am not good at in English, so my presentation consists of the pictures, very easy to understand. Just focus on the slide. I'm last time. Okay. Today I will speak on the resilience of climate change. Too often we consider climate risk as something that it could be happen in the future. In 2022, we got a harsh slab across the face. And Typhoon Hinnamno proved that climate risk is today's problem. So today, I would like to share our lesson learned, and then I hope it will help you to prepare the future. My subject is 135 Days Miracle. First, I will explain how the physical climate risk became reality. It is September 6, 2022, 6 a.m. Hinnamno was a super typhoon that made a landfall on the Korean peninsula. It was massive. Record-breaking storm. They happened once every 500 years. Wind speed was 56 meters per second, dumping 110 millimeter rain per hour. But Pohang Works had enough drainage capacity. We felt we were safe. That night would prove to be the longest night in POSCO 54-year history. Preparation began a week before the typhoon hit. First, a task force was established. The report directed to the CEO. Then sewers was cleared and drain system was enhanced. because the management placed utmost priority on safety. A decision was made to shut down all lines. Gas and fuel supply was suspended, and the power to our facility cut off. For the first time in 54-year history, all plant was powered off at Pohang Works. We were ready to face the monster. Looking back, the maverick move is what saved the Pohang Works. We call it the master stroke. Situation was under control. Then at 6 a.m., things changed very quickly. The nearby reservoir could not hold the rain. The gate opened. The river next to the plant overflowed. The rain mixed with soil becomes yellow sludge. Soon, 6.2 million tons of muddy water flooded our plant. It took an instant. Nothing could stop super disaster. 1/3 of steel works, equal to the 470 soccer field, went underwater more than 2 meters deep. That is enough water to fill the Burj Khalifa, the world's tallest building. The impact was a catastrophe. 36 factories and 118 production lines completely stopped. 60,000 pieces of facility and 1 million tons of product was caked in mud. But visuals speak better than words. Let's watch short video.
Typhoon Hinamnor brought up to 505 millimeters of rain per hour, causing flash flooding of streams in Pohang. The extent of the damage was great, and many roads were cut off or blocked, so the exact extent of the damage couldn't be measured. No one imagined that streams would overflow. This steelworks was flooded in a flash. So were the roads there. The situation inside the plants was dire. Most facilities were more than half submerged. But the sad thing was that workers had no choice but to just helplessly watch. The damage from the flooding was beyond imagination. The plants were filled with water and mud, as deep as tens of meters below ground level, and even up to 2.5 meters above ground in some areas. An unbelievable, terrible scene.
Yeah, so sad story. The video captures a situation beyond control. I have worked here for 29 years. On that day, I did not recognize the Pohang Works. It was dark and completely silent. But no video can tell full story. 0 casualties, and the most remarkable achievement with this tragic event is that we suffered 0 casualties and 0 explosions. How? Because of the maverick decision to stop all operation, the master stroke. Had we not cut the power and stopped the plant operation, recovery would have been impossible. Hence began 135 miracle. Second, I will share our restoration process, its outcomes. The preparation was effective. We prevented human casualty, but a crisis was blowing in the blast furnace that was cooling fast. The situation, the substation was submerged, cutting water power and utility across the campus. 6 days is the time given to prevent the hardening of the molten iron inside the furnace. We had to work with this critical deadline. It took our entire workforce race against this time. Ultimately, in 6 days, the heart of our steelworks began pumping again. The upstream process was saved in the emergency room, but we faced a long battle to recover in the downstream process. fighting two major challenges, the mud and the long lead time to get the replacement part. First, the mud. The underground culvert, 10 meters deep, 68 kilometer stretch, was flooded. 300,000 tons of mud caked inside. Second, long lead time for replacing critical parts. The main motor drive system for hot rolling mill was destroyed. It would take over 1 year just to get a part. This is when the bond that POSCO has built with local partners began to pay off. Local residents, the government, and the military and the industry associations showed up to help. Each day we were 15,000 strong. In total, 1.4 million people had participated in the restoration. Thanks to everyone's labor, the plant was drained of mud and water in 30 days. The torpedo car used to transport molten iron was damaged. Then, local competitor stepped up, loaned us their own torpedo cars. Also, Kip Shipbuilder, one of them, our customer, offered the high-capacity pumps to drain the flood water. This act of kindness from our partners was essential to relieving critical bottlenecks. Nothing short of the miracle helped to overcome our greatest hurdle. The lead time to acquire main motor drive system for hot rolling mill, normally it takes a full year. We are grateful for the generous support of JSW in India, other steelmaker in our global network. At the expense of delaying their own process, our partners step up to cut the lead time to 3 months. Imagine home appliance that have drowned in the mud. Likewise, our team was given the mud-caked electrical and electronic machines. We took them apart and washed down each part and brought them back to life. By repairing them on site, we accelerate repair and the restoration time. A clear lesson learned in the recovery process is the power of our partners and employees. Business partners came to assist in spirit of the shared prosperity. Our employees came with their spirit of shared ownership. They wrote the miracle that reduced recovery time from 500 days to 135 days. We took back a full year of operation. Finally, I will demonstrate how POSCO has built climate resilience. We learned that such a disaster is not an unusual event anymore because of global warming. We have fundamentally innovated our infrastructure to triple defense system. First, 3.6 kilometers long, 2 meters high flood wall was put up on the outer boundary. Second, flood barrier was installed at all substations. Finally, flood gauge protect 1,400 entrance. Now, dams may collapse and the rivers could overflow, but our steelworks will remain protected. Scholars help to model global climate change scenarios. As a result, we enhanced our drainage capacity by 35%. We have built a dual source of power and gas line, and finally, we now have a 10 megawatt starting generator on site. This enables self-generation. Even in total blackout, we maintain the power to our core facility. We no longer rely on external grid. Additionally, a year-old insurance against the natural disaster covered 35% of our total damages. Also, our business continuity plan, so-called BCP, was revamped. Super disaster response protocol placed against event triggered by climate change. And the dual production system ensure customer order get filled even during catastrophe event. Finally, recognizing that climate change dominates cooperative risk management, we have upgraded our ESG management initiative by adding Hyrex and the electric furnace. The 2050 carbon neutrality roadmap is supercharged. Also, we do a lot more communication with the local community that was fully engaged in our recovery. Hinnamno was woke us up the value growing strong with the community and our partners. They are our greatest asset. In the destructive aftermath of Hinnamno, we found our diamond, sustainable management. POSCO will not be deterred by a climate event. I hope this presentation is helpful. Let us build resilience against as a community of steelmakers. Thank you very much.
Thank you. I'm on? Yes. Thank you, Mr. Lim. Look, I think for many of us who work in our industry, that video is chilling to see. So much water and the recovery, I think, is fantastic. I'd also welcome to the stage Ms. Lim, who's my colleague from World Stainless, who has graciously agreed to help us, and Mr. Lim with some translation, if needed. So we have around half an hour, I think. Half an hour to talk about some of the issues that this raises. And I think we've heard certainly a diverse set of perspectives from the outside, the theoretical, and really what happened. And I guess I'd like to start with POSCO. I think your presentation, Mr. Lim, it made very clear the scale of the disruption and the complexity, and I think the achievement of the recovery. I'd like to explore perhaps not just the recovery, but what it changed within POSCO. So I guess my first question is, if you look back now, which of the assumptions which you made around operational resilience to climate change, in terms of where you thought you were, proved to be incomplete or incorrect when things really happened?
Incorrect.
Or incomplete?
Yeah, assuming.
Yeah, your assumptions, what you expected.
And I speak Korean in my translation here. Yeah. 그 과정 중에 가장 잘못된 거는 우리가 대응 대책을 히스토리컬 데이터의 베이스에 의해서 대응을 하다 보니까 지금은 기온이라든지 클라이밋 체인지가 굉장히 빠른 시점에 있습니다. 그래서 그런 부분들이 잘못되었는데 대부분 이번의 문제는 정부에서 관리하는 댐과 리버가 그런 인프라스트럭처들이 대부분 디자인이 예전 과거 데이터에 의해서 이루어져서 그 부분을 이번에 발생한 500년 빈도의 이 태풍을 방어하지 못했다고 생각을 하고 있습니다.
So our most fundamental assumption was that local public infrastructure would hold, and the dams and the rivers managed by the municipality were designed on historical data, and we trusted that baseline. But against a 500-year rainfall event, that design proved invalid. And with average temperatures rising and extreme natural disasters becoming more frequent, we cannot rely on the past data.
우리 포항 제철소는 한 면이 바다로 접하고 있고 양쪽은 강으로 접한 제철소인데.
Our Pohang Steelworks is facing one side in the river and one side in the ocean.
이번에 피해를 입은 거는 리버사이드에서 피해를 입었습니다.
Our disaster came from the riverside.
근데 바다 쪽에 피해를 입지 않은 이유는 15년 전에 일본의 후쿠시마 원전이 그때 지진으로 인해서 쓰나미가 발생을 했는데 그때 저기 15년 전에 그 쓰나미에 대한 우리가 그 시뮬레이션을 했고 그때 방어책을 바다 쪽은 해놓은 상태여서 바다 쪽은 전혀 피해가 없었고 대응을 하지 못했던 강 쪽에서만 데미지가 컸습니다.
The reason there was no damage, it was intact in the seaside, was that we saw the event in Fukushima in Japan 15 years ago, and they were disturbed by the tsunami. And so we were prepared for that event, so our seaside was intact.
That's really interesting. Rizwan, does this, I mean, this is a lived example of exactly what you were talking about. Does this, I mean, based on this, I guess you would expect other steelmakers, all things being equal, to be exposed to these kind of risks and this to happen again.
No, certainly. I think this is an experience that should be shared with the community, and especially if you find yourself, if you are in a situation which might not be directly comparable to that. Even if you are inland, it does not mean that the risks are not there. They might be of a different nature, but the way they went about mitigating that, at least now for the future, they have put together a plan.
Yes.
That if something like that strikes again, that they are prepared in some way or some shape or form. So there is some learning there. I think if there is a case study like that, that should be shared with the rest of the community as a best practice. And you can learn quite a lot. Even if you are by riverside, there could be things like even drought. So the material cannot come in, or it cannot leave if there is a drought there. So what do you do then in that time? So extreme weather events, they can become quite a norm.
Yeah, I mean, what struck me as well was the interconnected nature of what happened. It wasn't one thing, the typhoon, water, flood, it was almost a cascade. And I guess, Ben, from your perspective, are these kind of operational independencies that are attracting attention from the insurance industry? Because it's not one. I mean, you touched on this in your presentation, and I think Maryam talked about it as well.
Exactly that. The biggest threat we have now is, again, historically we've always used historical models to try and predict the future, but actually what we're seeing now is everything is such a sophisticated supply chain, so interlinked, that actually the level of scenarios, the risk-based scenarios that we're having to run and future-looking secondary perils, what we call, are actually driving bigger losses than the original perils that we thought. So we're doing an incredible amount of work looking at supply chains, resilience in the supply chain, and again, business continuity plans should the original supply chain fail. And that's driving a lot of our decision making.
I mean, I think it's a really powerful message to steelmakers here present. If you haven't got a recovery plan for this kind of event, really think about it. Mr. Lim, you touched on some of the defences and what you've done. I guess the question is, what's physically changed at your sites? And have you taken some of the learnings to Gwangyang as well? Or is it purely a Pohang solution?
제가 좀 이야기 드리고 싶은 이야기는 우리가 물리적으로는 제가 as I presented in my P50, we installed the triple defense system. Yeah, and this problem is happened from infrastructure managed by government. The government don't prepare for the big typhoon. So, in the government sometimes a little slow to action. So, the corporate, the company have to protect by themselves. So we installed the triple defense system, 2 meters high, flood wall, and our substation receiving the electricity is installed a little 4 meters high. But in this case, it's impossible to protect the flooding because the dam's flood gate is opened instantly. So big wave attacked our Pohang works. So we made a second flood wall to the substation, to the receiving electricity. And the third is a flood gate. This is our physical system. Gwangyang is the same. We installed like that. So, and the second, our protocol to response to the disaster is don't have that kind of a super disaster. So we made a sophisticated manual for the super disaster. If we did not receive the electricity, in that case, what can I do? If we did not receive the natural gas, in that case, what could I do? So we make a dual protection system. And third, we make the real communication system between government and our company. Because the river or dam is managed by government. So when something happened in the government infrastructure side, in the case we receive the signal directly, so we can protect our side. In the supply chain, also we revamped. Before this disaster, we operated Pohang works and the Gwangyang works independently. And so with this kind of disaster, we operate both Pohang, Gwangyang works in the simultaneously dual production system.
Yes.
So,
and can I ask how much it cost? Do you have a feeling as to not the impact, but also the protections that you had to put in place? Even ballpark I think would be interesting.
I remember Korean won. I cannot calculate exactly dollars.
Okay, give us the one. We'll work it out.
One, it is a little, a big amount of money.
A lot of money. I get that. I mean, Ben, if you're insuring POSCO or a company like this after this kind of event, what kind of actions are you looking for to make the site insurable?
Well, I mean, what interested me from your presentation was you said that only 35% of your costs were recoverable by insurance. For me, that's disappointing from an insurance industry. I mean, it shows that, I don't know, the product wasn't fit for purpose. There's improvements there. But also, again, the fact that you've had to build these defences after something has happened shows that, again, like I said, the insurance industry is not where it should be in that situation. The insurance industry can share learnings across multiple industries, and what strikes me there around the flooding was very similar to the experiences we had in the oil and gas industry after Hurricane Katrina in New Orleans, where the levees failed and New Orleans flooded. Or with Queensland, when the dam in Queensland overtopped and the mines flooded. You know, these are events that happened, and the fact that we're not spreading that knowledge to other industries and overlaying those scenarios. Whereas if we had early engagement, we could sit down with the site managers and say, with our risk engineers, and say, have you thought about this? Have you thought about this scenario? If you installed this now, this would prevent this. I mean, insurance is too reactive still. Yes. We do pay claims, but what we should be doing is focusing on preventing claims, early engagement, really sort of bringing stories, and situations and learnings, so to avoid
So
this happening.
what does that look like? You talked, I mean, that struck me in your presentation, Ben. You saw early engagement as really important. What does early engagement look like? As we go through the transition, there's still sustaining capital going into our industry and the transformative capital. What does early engagement with your industry look like in practice?
From concept stage all the way through. So again, we've got examples of where we've got involved in technology. A great example is I worked very closely with Shell Oil Company when they built the first floating LNG plant. Again, they knew it was going to be it was a $10 billion asset. B, it was the first of its kind, prototypical technology. And they knew that they needed the insurance market on site to get the banks on site. So they invited us at the design stage we sat there with the engineers, with the designers, saying that will be an issue, that will be an issue. Again, we would need it to be weather resilient, where you're locating it. We did a lot of work on when they were towing the vessel from the Korean shipyard through to the final location. Again, we were very heavily involved in when they did that, how they did that, who did it. We have warranty surveyors that go out and make sure they do it properly. These are all services that insurance companies can provide at the start. And now that project is now hugely successful and now has been replicated 3 or 4 times over.
I mean, it strikes me, Rizwan, that a lot of these are design decisions, right? These resilience aspects that become harder and more expensive. I mean, as a technology guy, it's going to be more difficult if you have to make changes late in the project, right?
Indeed, because it's an interesting point that Ben brought there, that involving the insurers at the early stages when you are planning something, because you might not have thought about certain things that they have got an eye or already have got an overview of, or can somehow transport the learnings from some other industry. Let's take the example of the decarbonization, because if the steel industry is trying to decarbonize itself, you want to make a site which is going to make steel using hydrogen. So have you thought about certain things that will change? Because it will be a totally different thing as compared to the other technologies. When I mentioned the context of the steel industry there, that most of the water that we have, or that we use, it stays in circulation. But if you put a hydrogen-based DRI, you have to think about the consumption bit also, which is going to go very, very high, especially if you are making hydrogen on site. I was struck by one project that was being thought about in Australia, where they wanted to make hydrogen, because there is plentiful of green energy there, but nobody thought about that. Okay, we have to start thinking about desalination. So that project just fell through halfway. Oh, sorry, we don't have fresh water. So all of those kind of things there that one needs to be very mindful of when planning or thinking about changing something.
I think just to comment on that, I mean, we've got great examples that we're experiencing at the moment around decarbonisation. We had a chemical plant that were installing wind farms on their site to create green energy to reduce their carbon. And they spoke to us and said, look, this is what we're planning to do. It's a great innovation for us, and it's going to reduce our carbon on our energy footprint. And we said to them, yeah, fantastic. What happens if there's an explosion? What happens if you have a chemical leak? If you have a chemical leak and you release a toxic chemical into the environment and you have a wind farm stood next to it, expelling air, where are you going to blow that toxic chemicals to? And they looked at us and was like, well, we don't know. But we would say, and we said, well, we've modelled that, and that chemical is going to head to Houston. You're going to blow toxic chemicals into Houston. And now I don't want to pick up that US lawsuit, you know. And that's the thing. So they then said, well, okay, we need to stop. We need to have a think about this. I mean, and again, these are the things we look at. And again, when people are talking to us about retrofitting their energy supply to hydrogen, we look at the metallurgical breakdown of their infrastructure and say, well, hydrogen will embrittle that infrastructure. Hydrogen's more explosive than you're used to. How are you going to prevent that? And again, if there is an explosion, how are you going to protect your people, your assets? Because your current site isn't designed to withtake that explosion, and the local community is a lot more vulnerable than it was when you installed that plant 30, 40 years ago.
It really raises the profile of process safety, which we generally think about internally, to much more the external perspective. It's very interesting. Mr. Lim, I was also interested, how is the conversations that you're having with perhaps your insurers and your audit and risk committee of the board of POSCO, have they changed as a result of this experience?
통역을 좀 해야 될 것 같은데. 보험 같은 경우는 우리가 very 럭키했다고 생각을 하고요. 1년 전에 저희가 보험을 들었는데 그 1년 후에 사고가 터져가 보험을 받아가지고 보험에 대해서 훨씬 더 중요하게 저희가 생각을 하고 있습니다.
As for the insurance, I think we were lucky. We took our insurance a year ago, and after receiving help, just as an incident occurred a year later, we now consider insurance to be much more important.
그리고 근본 사건을 겪으면서 회사의 저희 경영진에서도 이러한 이런 클라이밋 리스크가 진짜 실제로 일어나는 현실화된 문제라는 부분을 인식을 하고 있고, 그런 측면에서 저희가 그 ESG 관점에서 하이렉스도 저번 달에 착공을 했고, 저희가 250만 톤짜리 전기로도 이번 달에 가동을 합니다.
So our management team recognized that such climate risks are real, not a theoretical or PR activity. So in terms of our ESG perspective, we have started the construction of hydrogen-induced steelmaking last month, and also we are starting operation of 2.5 million ton electric arc furnace this month.
Thank you. Now, this is supposed to be a conversation with the steel industry, and also will shout at me if I don't give our audience an opportunity to be part of the conversation about this. I'm blinded, but I see a hand over there. I can't see who it is, so please introduce yourself. Caroline, okay. Oh, that's not on, I don't think. Can we have the microphone on? Otherwise, we won't hear you. Or maybe...
Working?
Yes.
Yes.
Excellent.
Okay. Mr. Lim, thank you very much for sharing that story. And I'm really glad there were no casualties. Very impressive. You just mentioned at the end of the technical changes you made, and then you also mentioned the ESG, the decisions on HYREX and the EAF, and the decision to invest more in community communication. So I'd like to ask you about those two elements, not the technical ones. You implied that because of the damage caused by an extreme weather event, which is going to get more common due to climate change, that encouraged or drove the decision to go for the EAF and for HYREX. It added momentum to decarbonisation in the company's decision-making. But you didn't say that explicitly, but that was the implication. So I would just like to understand, to what extent did this weather-related disaster encourage a change in thinking on decarbonisation? I do not wish that kind of disaster on any company, but I am interested if it affected decision-making. And secondly, the lessons about community engagement were very, very striking. Young people in South Korea are now taking a court case against POSCO for the impacts of the blast furnace on them and their future. And I was just wondering, does this kind of youth engagement or contestation, does that now have more significance to your leadership because of this kind of experience? How do you view that community and youth engagement differently now? Thank you very much.
Okay. Yeah. The first question is simple. And our company decarbonized in the future. But the problem is the cost. And now we start the Hyrex. In the 2028, we manufacturing steel by using Hyrex. And this month, we start electrical arc furnace, 2.5 million tons. And now, we worry about the cost. The cost, the production, the material will be increased there. And then, the price is the same in the market. Between green steel and normal steel. So the green steel premium have to be discussed in our society. So we can invest more money to Hyrex or electric arc furnace. So anyway, we will try to do our best decarbonizing. And the second question about the blast furnace. And we need steel now. We need steel. And then we cannot enough steel using our other furnace instead of a blast furnace. So we also research the CCUS, also the decreased carbon using a blast furnace. Also, we have research about the hydrogen reacted furnace. So, and then our young people in Korea, how do they thinking about that? So anyhow, they want to industry is developed, and also they were also green society, both of side. That's
Thank you, Mr. Lam. Ed?
Can you hear me? Yes. Yeah, Ed Heath-White. Currently working for Europa on the iron and steel BREF, but back in 2007 I was works engineer in a steel plant this rolling mill in the UK, in Rotherham. And in Sheffield and Rotherham we had three sites, and we had a 1 in 200 year flood event. So above our Stocksbridge site the reservoir overflowed and the river went through our works, our billet mill. So the video brought back memories to me, because we have exactly the same video going through our billet mill. So that event cost us £63 million, uninsured loss. Tata Steel didn't have flood insurance. We then installed, so we did flood risk management and assessments by civil engineers, and we installed flood defences at Stocksbridge. Of the other two sites, they weren't really badly affected. They were back up and running in 2 days. But the Stocksbridge site took 3 months to get going again, and £63 million. So that's what we immediately did. We put in flood defences, hard flood defences.
Was it on your risk register, Ed? Was this something that featured you knew could happen?
Because we had major incident plans, and the engineers block at Stocksbridge, on the wall it has where the previous flood levels were. So the black stage there is probably where the 20 so the 1950 flood was. This site is started in 1840, so it's been there. Water was the original power source. Okay, so where the black stage is, that's the sort of level of previous flooding. In 2007, it was up to the top of the climate conversation, so above your heads. So it was a significantly, bigger event. Some factors there: the reservoir was full, Yorkshire Water were conserving water. It was a drinking water reservoir. So it was in June, it was full. So when we had the 1 in 200 year event, rainfall, it just went straight over the top, basically. They had to open the floodgates to prevent damage to the reservoir itself. And indeed, Sheffield flooded. And, at Forge Masters, you saw helicopters rescuing people out of the steelworks. So that's what happened in 2007. And then fast forward to 2022. We didn't really do anything in the intermediate years, but then we started looking at climate change adaptation and ISO 14090. So we did a full climate change risk assessment of all of our sites. We used that standard. We also used, so in the UK you have the CCRAs, so climate change risk assessments, which are national things. So we used CCRA 3, and that told us what the risk was in our particular plants. So we had all the data we needed to actually do that climate change risk assessment. And since then, what we've done, well, what we're planning to do, because we didn't have any money at the time, we now know that the flood defences at Stocksbridge, which were built for a 100-year lifetime, we're going to have to do something with them in the mid-2040s because they won't last 100 years. So we're going to have to reinforce those flood defences. So we've done quite a bit of work, but in 2007 we shared that in the UK, but we didn't share it elsewhere. But it's exactly the same event, reservoir overflowing. I also remember in 1997, when I worked for Avesta Sheffield at the time, and the Cogna steel mills in Italy were those big Italian floods. And we produced steel for them while they got their steel plant back working again. So this isn't new.
It's real, right?
This is real. It's been happening over the years. One thing I'll say about the current iron and steel BREF, and also for our permit currently in the UK, is that climate change adaptation risk assessment is a requirement in the UK permits now. So the Environment Agency said you must do climate change risk assessment and you must submit that to us to help us with our planning. Also, I am chairman of a charity called the Steel Valley Project in Stocksbridge, and the Environment Agency provided us with funds to do natural flood management. So we live in a valley with steep sides, so we've done a lot of work now in slowing down. When it does rain, that water used to go straight into the river. Now we'd have dams up the valley, natural dams made out of wood, and that slows down the rainfall. So there's a lot of work going on in the background that's mitigating some of that. And also, it helps us when we're in a current situation. I still work for Specialty Steels part-time. When somebody's looking to buy us and they want insurance. Yes. So that sort of thing that we've done helps us, or will help the new owner get insurance for that business. So it's, that's a practical example, but that video from the POSCO was
chilling, isn't it? I mean, we're almost out of time, but I was just keen to touch on that upgrading issue, Ben. Is that something you found you're having conversations around? Existing defences just aren't up to it anymore?
Yeah, I mean, I think there's two things there. I mean, part of our regulation under our capital management, the government and the EU and all the regulators we have to deal with, we have to model our solvency on various different climate change realities. So we do present day what we call aggregations of it could be houses in postcodes, or for me it's sort of plants in different locations. We then have to apply 5 RDSs, risk sort of disaster scenarios, for 1 degree, 1.5 degree world, 2.5 degree world. And then we have to report that to the regulator to say if there is a 2.5 degree, we've got enough capital to back that. So But a lot of that now is we're now offering that to clients and saying, again, you've built these sea defences in 2007, and they were in a 1 in 100 year. Actually, our modelling, if we hit a 2.5 degree world, they're not good for that. So now you can start building that into your business continuity plan, your risk register, and actually saying, well, actually, instead of being bottom left in the green, we should move that to amber. And again, when you've got capital projects and stuff like that, you can start building it in. I mean, it's always harder. Again, it's always harder for us to go into site and recommend retrofitting, because I mean retrofitting is incredibly difficult on all sites, particularly sites like yourselves that have been up and running since the 1800s. But again, we are, all we can do is advise and give the data that we've got and provide that and say, look, actually, we recommend that you build this into your long-term thinking, because what you've got works for now, but it doesn't work for the future.
Fantastic. I think we're almost,
I think there was one question over
we are out of time, but if there's one more short question, I think we can probably take that. Given we gave you extra coffee time earlier, so.
Is that working?
Yes.
Yeah. Okay. So John Cuddy here with the Canadian Steel Producers Association. Just a question for Ben, actually. It sounds from the examples that you provided that there are definitely situations where accessing capital, requires that climate risk assessment and kind of mitigation. Are there examples, or do you have examples where it's not just a requirement, but there's actually quantified cost of capital reductions associated with having that? Because it's one thing to say, okay, well, sorry, we're not going to lend to you if you don't do this, and that's understandable. But from an encouragement perspective, or making something possible in terms of propagating that kind of risk mitigation across an industry where people may be more or less exposed, having a reduced cost of capital would be an interesting opportunity.
Yeah, I mean, we work incredibly closely with lenders, and I mean, banks want to know that, I mean, the one thing banks are very scared of at the moment is this stranded asset, where they're lending, long-term lending on assets, 25-year lending, and they want to know that site is going to produce for 25 years, and that company is going to be ongoing for 25 years to pay back the loan. Again, one of my frustrations in the insurance industry is we're very short-sighted. We offer, you go to a bank, you get a 25-year loan, and they expect you to pay that back over 25 years, and they say to you, how are you going to manage that risk for 25 years? And you go, oh, I'll buy insurance. And then you come to my company and we go, here's an insurance policy for a year. And you're like, great. And then come back next year, and then what happens is my CEO leaves, I'll get a new CEO, and he goes, Ben, we don't want you to do that anymore. And Canada's a great example, because I've spent a lot of time with the Canadian oil sands, and that is an industry that has a huge spotlight around climate change. And again, I worked with those guys to try and build resilience into their model, trying to explain their business model and how to reduce the carbon tax, and all this sort of stuff into their model. So, and insurance played a big part in that, but also gave them the liquidity to go and change their methodologies, invest in equipment for longer term. So, I mean, a good insurance product will build resilience in, so that people can go to their lenders and say, this is a going concern for 25 years, and the capital's protected for 25 years, the output is protected for 25 years. And a lot of what we're doing now is with the technology, the prototypical technology, is we're ensuring the performance of that technology. So again, we've got examples now where banks won't lend on a prototypical technology, or the interest rate would be 8%, because they're like, we don't know if that's going to perform for 10 years. Well, we'll give you a performance guarantee product that says we guarantee that if it doesn't hit this output and this company can't make the payments, we'll bridge that gap. And that brings the lending cost down, which means you can develop that. And these are the sort of solutions that we're working with clients on. But again, we can only do that if we understand the technology at the drawing board stage.
Thanks, Ben. I am going to draw things to a close now. And this is the beginning of a conversation. I think we've had a great engagement with as worldsteel, with the insurance industry and with Maryam. This is the beginning of an ongoing process. We're going to keep working together, and we'll engage you guys as members in that. And I think from this session, I'm really grateful. I think all of our speakers and our perspectives. And I hope you go away with maybe 2 clear messages. One is, take another look at your assumptions around climate risk, around exposure. You know, I'm looking around, I see a lot of people here with steel plants, Mr. Chairman, right on the waterfront. So some of those images must have been pretty chilling. So let's go back and talk about those issues with your people, your operations people. I guess the second message maybe is the people responsible for operations, finance, risk, insurance, and infrastructure probably need to be having these conversations more often and earlier, so that if something does happen, you're better equipped to handle it. So I think I'll close on that point and let you go. Thank you, Ben, Rizwan, Mr. Lim, Ms. Lim. Thank you very much for your support and your conversations, and we can obviously continue into the break if need be. So thank you all.